Hey everybody, Mr. Piercy here with part 2 of our conditional statements lesson. In this part, what we're going to be talking about primarily is how we're going to take a conditional statement and rewrite it. So just as a reminder, a conditional statement is a statement written in an if-then form where the portion that follows the word if is the hypothesis, and the portion of the statement that follows the word then is the conclusion. So what we're going to be looking at here is how you rewrite them and create new types of conditional statements. We have 3 different kinds. We have a converse, we have an inverse, and we have a contrapositive. Now each individual statement, converse, inverse, and contrapositive, each one of those is written from the original conditional statement, meaning I don't have to have the inverse in order to be able to write the contrapositive. Everything comes from the conditional statement. Now, in our conditional statement, it reads, if the measure of angle A is equal to 15, then angle A is acute. And they're highlighting in different colors the hypothesis and conclusion. So it's the stuff that you saw in the previous video. The converse, the difference between the conditional statement and the converse, is going to take the hypothesis and conclusion, and it's just going to change their order. So in this case, you see the conclusion comes first, followed by the hypothesis. And this is how we read it. It says if P then Q, and of course the arrows here, then we would say if Q then P. We put the hypothesis first. We put the hypothesis second for a converse statement. Now for an inverse statement is going to take the conditional statement and it's going to negate things. It's going to negate the hypothesis and the conclusion, meaning that we add the word not, like it does not, or it is not, or we don't have, or something like that. It's just whatever, if it was positive before, it's negative. If it was negative before, now it's positive. We just negate it, kind of like what we do in a normal algebra problem. So here, the original statement says if the measure of angle A is 15, then angle A is acute. So that's the original conditional statement. Well, the inverse keeps the order of the original statement. All it does is negate the hypothesis and conclusion. And we can see it's negated right here with the not equal to symbol, and it's negated right here with the actual word not. And that's what these little squiggly lines are. I know it might be a little hard to see. So we have a little squiggle with a P and a little squiggle with a Q. And that is if not P, then if not Q. That's what the little squiggle part means. We're negating the hypothesis and the conclusion. So the final one, the contrapositive, again, all of these 3 statements can be written independently of each other from the conditional statement. However, the contrapositive is helpful to write if you've already done the converse. If you've already done the converse, it's basically you're just going to negate the converse. But anyway, we don't need the converse, but if we have it, we could use it. So from the conditional statement to create the contrapositive, we're going to reverse the order of the hypothesis and conclusion and negate them at the same time. So you can see here in this column is where I'm looking at, we're going to say if not Q, then not P, meaning that we change the order of the hypothesis and the conclusion, and we negate them. Now, in my experience as a teacher with this material, this is something that students generally pick up pretty well. Even looking at the tables, it'll start to make sense, but it's really going to start making sense when we actually write some statements. Now, before we actually start writing our statements, this is the last thing that we're going to talk about, because before we start writing our statements. So far, we've been talking a good amount in our previous lessons about when something is true and when something is not true. And if something is not true, having to create a counterexample to explain why it's not true. Well, all of the conditional statements, the converse, the inverse, and the contrapositive, All of those follow a true-false logic as well. Those statements are either true or they're false also. Now, what this is kind of telling you, the conditional statement, whether it is true or false, the contrapositive has to have the same truth value. Meaning if the conditional statement is true, then the contrapositive also has to be true. And let me go ahead and pick a different color here than what they have. Let's go red. If, for some reason, the conditional statement was false, then the contrapositive would also have to be false. And it goes the same thing with the converse and the inverse. These two statements are tied together with their truth values. If one is true, the other has to be true. If one is false, the other has to be false. So here, if the converse was true, then the inverse must also be true. Now, it's possible for all four statements to be false, and it's possible for all four statements to be true, but if the conditional or the truth values of the conditional and the contrapositive statements are tied together, and the truth values of the converse and the inverse are tied together. So now let's go ahead and practice how we're going to write some statements. Now, before we, here on this page, I'm asking you to identify whether it's true or false, but we're going to do that last. So first, let's go ahead and write the converse statement. Well, the converse, all we're going to do is reverse the order. So I'm going to say if Q, then P. So I want to make sure I identify the hypothesis and the conclusion. Well, the hypothesis is the original part here, the beginning of the statement after the word if, and the conclusion is the second part of the statement after the word then. So the way, let me change colors here so that way the blue doesn't all blend together. And everything's too black and white. Let's see. I don't know what colors show up good for you guys. Let's just go red. I think red will work. Okay, so the converse statement. The converse statement is going to take the hypothesis and conclusion and reverse them. So I'm still going to begin with the word if, but instead of writing what was originally in the hypothesis, now I'm going to write the conclusion. So I'm going to say if the figure is a quadrilateral, and I'm going to abbreviate a little bit, if the figure is a quadrilateral, then, and we'll put the hypothesis next, the figure is a square. So that is the hypothesis. Now let's go to the inverse. The inverse is going to negate the hypothesis and conclusion, but they stay in the same order. So I'm going to say, if not P, then not Q. So the inverse here, the way that we're going to change the conditional statement, we're going to add the word not there somewhere. So if the figure is not a square, is how I'll start the inverse. If the figure is not a square, then, and we have to include the not part of, we have to negate the conclusion also. So we're going to say it is not a quadrilateral. And the last one here, the contrapositive, this one's going to do both at the same time. It's going to reverse the order and it's going to negate things. So I'm going to say if not Q, then not P. And now let's go ahead and write this one. And let's see what would be a nice color that'll show up for you guys here. I think we could do that one in purple. So the contrapositive will read something like, if the figure is not a quadrilateral, then the figure is not a square. So those are the three ways of rewriting a conditional statement. And if you pay attention to what we were doing in the previous lesson, this is what happened with the bumper stickers. The original statement on the bumper stickers was talking about when things were true or false. Well, now, and the three other bumper stickers were rewritten really in this form, and we just didn't know it at the time. So now we want to identify the truth values of these statements. Well, let's look at the original conditional figure or statement. Is that statement true or false? If the figure is a square, then the figure is a quadrilateral. Well, that is true. So according to our truth table, the one that we just saw, if whatever the original statement is, the contrapositive must follow the same thing. So I'm going to just say that this is true. Now let's actually take a look at the statement and see. If the figure is not a quadrilateral, then the figure is not a square. Well, that is very true. If the figure isn't a quadrilateral, it can't be a square. So if it's a triangle, it can't be a square. If it's a pentagon, it can't be a square. So if it's not even if it doesn't even have four sides, there's no way that it can be a square. So we are seeing the truth values holding up for the conditional and the contrapositive. Now let's look at the converse and the inverse. So let's start with the converse, the one in red. If the figure is a quadrilateral, then the figure is a square. Well, that is very false. Why is that false? Well, I could have rectangles, I could have a rhombus, I could have all kinds of parallelograms. Those are all counter examples to show why that statement is false. So moving on, let's look at the inverse. The inverse, according to our truth table, must also be false. So let's take a look at why. If the figure is not a square, then it's not a quadrilateral. Well, that's also false. Yeah, we can have quadrilaterals that aren't square, and we can use the same counter examples, rectangles, rhombuses, parallelograms, trapezoids. Pick a quadrilateral, and that's the counter example for the inverse statement. So moving on here, I want you guys to take the conditional statement that's been provided for you. If a vegetable is a carrot, then it contains beta carotene. Well, a lot of students in class are asking, well, what's beta carotene? Well, beta carotene is basically vitamin B6, or maybe vitamin B12. I'm not sure, but it's just a vitamin. So if a vegetable is a carrot, then it contains beta carotene. And I want you guys to pause the video and write the converse, inverse, and contrapositive for the conditional statement, and then determine their truth values. And when you're ready, hit play again and come back and check your answers. So I'm going to presume everybody's done what I'm asking you to do, so let's take a look at the converse. Remember the converse, we changed the order of the hypothesis to conclusion. So we get a statement that says if a vegetable contains beta carotene, then it's a carrot. The inverse statement negates the hypothesis of conclusion, keeping them in the same order. So we wind up with a statement that says if a vegetable is not a carrot, then it does not contain beta carotene. And finally, the contrapositive, we negate the hypothesis of conclusion and reverse the order. We wind up with if a vegetable does not contain beta carotene, then it's not a carrot. So here, to help us with the truth values if we need it, This might be a little hard to see. Even standing in front of it, it's a little difficult for me to read. But we have, going from the top row from left to right, we have sweet potatoes, butternut squash, pumpkin, and diced cantaloupe. Middle row is papaya, red peppers, and then the bottom row gives us tomatoes, mangoes, apricots, and grapefruit. Now I know not all of those are vegetables, but we definitely have vegetables besides carrots that contain beta carotene. So the original statement is true. So that means the contrapositive must be true also. So let's look at the converse. If a vegetable contains beta carotene, then it's a carrot. Well, sweet potatoes contain beta carotene and it's not a carrot, so that's false. And so the inverse is also going to be false. Now, at the beginning of the lesson, in your notes, going back to the previous video, I asked you to write two conditional statements that where one was true and one was false. Okay. Now what I want you guys to do is write the converse, inverse, and contrapositive of those statements and determine the truth values of those the way that we have for our last couple of examples. But that, I think, is pretty much going to wrap it up for what we're doing with biconditionals. So if you have any questions, make sure you email them to me or leave me comments in the Google Classroom, and I'll be happy to help you with them. And until next time, ladies and gentlemen, thanks for watching, and we'll see you soon.